Welcome students to ninth lecture of fuzzy sets, arithmetic and logic. In the last class, we have discussed fuzzy numbers and we have seen different types of fuzzy numbers. In today's class, we shall study arithmetic operations on fuzzy numbers. Question is how to apply arithmetic operations on fuzzy numbers, because a fuzzy number is not a unique number, it is a set characterized by its different alpha cuts, which are closed intervals on the real line. Therefore, since the alpha cuts of a fuzzy number are closed intervals on R, for arithmetic operations on fuzzy numbers, we resort to what is called interval based arithmetic. The basic theory is as follows. To have unary operations such as say reciprocal, exponentiation, we use alpha cut of the fuzzy number A apply interval arithmetic and then get back the answer from the output of the interval arithmetic operation and consider that to be the alpha cut of the answer. For example, given a fuzzy number A, we compute A inverse as follows. From A, compute alpha cut of A, apply inverse on that interval to get alpha cut of A inverse, and from there get A inverse, that is reciprocal. Similarly, for binary operators, such as plus, minus, multiplication, division, we get for two fuzzy numbers A and B, their corresponding alpha cuts. Then apply the operation on them to get the alpha cut of the answer, and then get the answer from the alpha cuts. That is A operation B, where O may mean plus or minus or slash or multiplication, such binary operators. What we do? We compute alpha cut of A and alpha cut of B, then we apply interval operation on this alpha cut of A and alpha cut of B, and from there we get alpha cut of A operated on B, and from there we recover A operation B. That is the intuitive idea for computing fuzzy arithmetic. Therefore, as a first step, we study interval arithmetic or interval based arithmetic. So, if A comma B and C comma D are two closed intervals, then A comma B inverse is equal to 1 upon B to 1 upon A. Since in an interval B is greater than equal to A, therefore, when we take their reciprocals, 1 by b has to be smaller than 1 by a, and therefore, this is going to be the corresponding interval for reciprocal. What is a comma b plus c comma d? This is the interval a plus c comma b plus d. So, for addition, we get the answer by adding the lower bounds of the two intervals as the lower bound of the output, and the upper bound of the two intervals, their sum is going to be the upper bound of the output. What is a comma b minus c comma d? It is not a minus c comma b minus d. So, people often make this mistake. This is not correct. In fact, a comma b minus c comma d is a minus d comma b minus c. Why? Because in forming the interval of the output, we look at what is the smallest value that it can attain and what is the largest value that it can attain when we apply the subtraction on these two intervals. The difference will be maximum, or rather than the lowermost value of the difference is going to be a minus d. When a is the smallest and d is the largest, the difference is going to be the least one, and when the b is the highest and c is the smallest, their difference is going to be the largest one in the intervals. So, let me give you examples. What is 2 comma 5? It is reciprocal. This is actually is equal to 1 by 5 to half, and we know that 1 by 5 is smaller than half. One has to note that when we were taking reciprocals, the interval should not contain zero, because if 0 is inside, then 1 by 0 is not defined. In a similar way, minus 3 comma minus 1 reciprocal is equal to minus 1 to minus 1 by 3. Example for addition: 2 comma 5 plus minus 3 comma 8 is equal to minus 1 to 13. To understand that, suppose we take any arbitrary number from this interval and one arbitrary number from this interval. What is going to be the smallest value for that one? The smallest value comes when I take the smallest one here and the smallest one here, and their addition gives me minus 1. In a similar way, the largest value of the sum is going to be the sum of the largest value of this interval and the largest value of the second interval. What is 2, 5 minus 3, 8? This is going to be the smallest value that we can attain by subtracting any arbitrary number chosen from here from any arbitrary number chosen from this set. That comes when this number is smallest, that is 2, and this number is the largest, that is 8. Therefore, the smallest possible value that we can get is minus 6. On the other hand, the largest possible value we can get is 5 minus 3 is equal to 8. If we understand this, then we go to the next step. What is a comma b multiplied by c comma d? Again, as before, we want to get the interval that should contain all possible values which come as a product of any arbitrary number chosen from this interval and any arbitrary number chosen from the second interval. Since the minimum of that will depend upon the respective signs of these, we will get the interval to be the minimum of the 4 possibilities AC, comma BC, comma AD, comma BD, and the largest value is going to be maximum of AC, comma BC, comma AD, comma BD. So, let me illustrate. What is 1, 2 star 3, 4? This is equal to minimum of 1 into 3, 2 into 3, 1 into 4 and 2 into 4 to the maximum of 1 into 3, 2 into 3, 1 into 4 and 2 into 4, that is minimum of 3, 6, 4 and 8. Therefore, this is going to be 3 and maximum of 3, 6, 4 and 8 is going to be 8. Therefore, what we are getting is AC on this side and BD on the upper side. But consider minus 1 to 2 multiplied by minus 3, 4. Therefore, this is going to be the interval minimum of minus 1 times minus 3, 2 times minus 3, minus 1 times 4 and 2 times 4 and maximum of minus 1, minus 3, 2, minus 3, minus 1, 4 and 2, 4 is equal to minimum of 3, minus 6, minus 4 and 8 to maximum of 3, minus 6, minus 4 and 8 is equal to minus 6 to 8. A third example, what is minus 2 minus 1 times 3 comma 5? This is equal to minimum of minus 6, minus 3, minus 10 and minus 5 to maximum of minus 6, minus 3, minus 10 and minus 5. This is going to be minus 10 to minus 3. So, I feel that the concept of multiplication of intervals is clear. With that, let us look at division. A comma b divided by c comma d is defined if 0 does not belong to c comma d, and in this case the output is minimum of a by c, b by c, a by d and b by d, comma maximum of a by c, b by c, a by d, b by d. Example, minus 3 to 4 divided by minus 2 to minus 1. This is going to be the interval minimum of minus 3 by minus 2, 4 by minus 2, minus 3 upon minus 1 and 4 upon minus 1 to maximum of these 4 numbers minus 3, minus 2, 4, minus 2, minus 3, minus 1 and 4 upon minus 1. So, this is going to be, this is 3 by 2, this is minus 2, this is 3, this is minus 4. So, this is going to be minus 4 and highest one is going to be minus 3 by 1, minus 1 is equal to 3. So, dividing minus 3 comma 4 this interval by minus 2 to minus 1 this interval, the output is this interval minus 4 comma 3. The following properties hold for interval arithmetic. One, a plus b is equal to b plus a and a multiplied by b is equal to b multiplied by a, that is addition and multiplication of intervals are commutative. Two, a plus B plus C is equal to A plus B plus C, and A star B star C is equal to A star B star C. That is associative. If we denote by 0 equal to the interval 0, 0 and 1 is equal to the interval 1, 1, then A plus 0 is equal to A and A star 1 is equal to A. That is 0 and 1 are identity for addition and multiplication. The above properties are very similar to what we have seen with respect to real numbers, but the following is slightly different. What is A star B plus C? In reals, we know that it is A star B plus A star C, but with respect to interval arithmetic, it is contained in A star B plus A star C. Example, consider 1, 2 star minus 1, 1 plus 2, 3 is equal to 1, 2 star one comma 4 is equal to minimum of 1, 2, 4 and 8 and maximum of 1, 2, 4 and 8 is equal to 1, 8, and 1, 2 star minus 1, 1 plus 1, 2 star 2, 3 is equal to this is minimum of minus 1, minus 2 plus 1 plus 2, which is equal to minus 2, and upper limit is plus 2, upper bound is plus 2 plus minimum of 2, 4, 3 and 6, which is 2, and this is 6 is equal to 0, 8. So, on this side we got 1, 8, on this side we got 0, 8. So, we can see that this interval is contained in this interval and they are not same. The above property is called subdistributivity. Subdistributivity. However, if for all B belonging to B and C belonging to C, B dot C is greater than equal to 0, then distributivity follows. Say for example, 1, 2 star minus 2 minus 1 plus minus 4 minus 2. Since all the members of B is negative and all the members of C is negative, therefore, these conditions hold. In such a case, distributivity holds. One, 2 star minus 2 minus 1 plus minus 4 minus 2 is equal to 1, 2 star minus 6 minus 3 is equal to minimum of minus 6 minus 12 minus 3 and minus 6 and maximum of minus 6 minus 12 minus 3 and minus 6 is equal to minus 12 comma minus 3, and 1, 2 star minus 2 comma minus 1 plus 1, 2 star minus 4 comma minus 2 is equal to minimum of minus 2 minus 4 minus 1 minus 2, maximum of minus 2 minus 4 minus 1 and minus 2 plus minimum of minus 4 minus 8 minus 2 minus 4 and maximum of these 4 numbers minus 4 minus 8 minus 2 and minus 4 is equal to the sum of the numbers minus 4 comma minus 1 plus minus 8 comma minus 2 is equal to minus 12 comma minus 3. Therefore, these two are same. Therefore, distributivity holds if all the elements of B and C have the same sign. Another property, if A is contained in B and C is contained in D, then A plus C is contained in B plus D, A minus C is contained in B minus D, A star C is contained in B star D, and A divided by C is contained in B divided by D when division is permitted. I like you to verify these results. Once the basics of interval arithmetic is clear, we now focus on arithmetic operations on fuzzy numbers. As I said, we will look at the alpha cuts, then we will operate on the alpha cuts, and from there we will try to recover the output. So, first, for example, addition. Addition for triangular fuzzy numbers can be done easily by adding the respective components of the triplets. That is, if A, B, C is a triangular fuzzy number and A main P is another triangular fuzzy number, then their addition is the triangular fuzzy number A plus M, B plus N and C plus P. I hope you remember the definition of a triangular fuzzy number. ABC denotes the TFN, which is having full membership at B, and between A to B it is rising linearly, and between B to C it is decreasing linearly. So, for example, let A is equal to minus 2, 1, 3 and B is equal to 1, 3, 5, then A plus B is actually the triangular fuzzy number minus 1, 4, 8. Now, we show it using alpha cut. A is equal to minus 2, 1, 3. Therefore, mu A of x is equal to 0 if x less than equal to minus 2 is equal to x plus 2 upon 3 for x belonging to minus 2 to 1 is equal to 3 minus x upon 2 for x belonging to 1 comma 3 and 0 for x greater than 3. Similarly, b is equal to 1, 3, 5. Therefore, mu b of x is equal to 0 if x less than equal to 1 is equal to x minus 1 upon 2 for 1 less than equal to x less than equal to 3 is equal to 5 minus x upon 2 for 1 for 3 less than equal to x less than equal to 5, 0 for x greater than 5. Now, let us find out the alpha cuts for A and B. We have already obtained the membership values for different x corresponding to the set A. Let us draw the membership function for A, which is at 1, this is 1, at minus 2 it is 0, and at 3 it is 0. So, we get this triangular fuzzy number, and we know that the Lx is x plus 2 upon 3 and the Rx is 3 minus x by 2. So, how do you get the alpha cut? Corresponding to any arbitrary alpha, we draw the line. Therefore, this interval is going to give us the alpha cut. So, let us call it x alpha and y alpha. So, at the point x alpha, the membership value is alpha. Therefore, x alpha plus 2 upon 3 is equal to alpha, or x alpha is equal to 3 alpha minus 2. Similarly, at y alpha, the membership value is alpha. Therefore, 3 minus y alpha upon 2 is equal to alpha, or y alpha is equal to 3 minus 2 alpha. Therefore, the alpha cut of A is equal to the interval 3 alpha minus 2 to 3 minus 2 alpha. In a similar way, we got mu b x is given by these equations. Therefore, if we call alpha cut of b is equal to u alpha to v alpha, then u alpha minus 1 upon 2 is equal to alpha implies u alpha is equal to 2 alpha plus 1. Similarly, 5 minus v alpha upon 2 is equal to alpha implies v alpha is equal to 5 minus 2 alpha. Therefore, alpha cut of b is equal to the interval 2 alpha plus 1 comma 5 plus 2 alpha. Therefore, on one hand we have the alpha cut of a is equal to this interval 3 alpha minus 2 and 3 minus 2 alpha. On the other hand, for alpha cut of b, we have 2 alpha plus 1 and 5 plus 2 alpha. Therefore, alpha cut of a plus b is equal to the summation of these two, that is 3 alpha minus 2 comma 3 minus 2 alpha plus 2 alpha plus 1 comma 5 plus, sorry, this is 5 minus 2 alpha. Therefore, this is going to be 5 minus 2 alpha is equal to 5 alpha minus 1 comma 8 minus 4 alpha. Thus, we get the alpha cut of a plus b is equal to 5 alpha minus 1 to 8 minus 4 alpha. From here, we get that putting alpha is equal to 1 cut of a plus b is equal to 4, and putting alpha is equal to 0, 0 cut of a is equal to minus 1 to 8. Therefore, we can see that we get the TFN minus 1, 4, 8, and if we look at, we have got this same TFN minus 1, 4, 8 when we have added the respective components, that is minus 2 and 1 is equal to minus 1, 1 plus 3 is equal to 4 and 3 plus 5 is equal to 8. This shows that if we are given triangular fuzzy numbers, then addition is straightforward, but we can arrive at the same result by going through the alpha cuts. Now, we need to find out mu a x for x belonging to a plus b. Since a plus b is equal to minus 1, 4, 8, therefore, mu a plus b of x is equal to 0 if x less than minus 1, it is x plus 1 upon 5 for minus 1 less than equal to x less than equal to 4 is equal to 8 minus x upon 4 if 4 less than x less than equal to 8 and 0 if x greater than 8. Once we know the triangular fuzzy numbers, the three triples, we can easily compute the membership values. In a similar way, we can compute A minus B. We had alpha cut of A is equal to 3 alpha minus 2 comma 3 minus 2 alpha, and alpha cut of B is equal to 2 alpha plus 1 comma 5 minus 2 alpha. Therefore, alpha cut of A minus B is equal to 3 alpha minus 2 minus 5 plus 2 alpha, this minus this, comma 3 minus 2 alpha minus 2 alpha minus 1 is equal to 5 alpha minus 7 comma 2 minus 4 alpha. Therefore, once we have the alpha cuts, we can get the fuzzy number. I leave that as an exercise for you to compute the membership functions corresponding to A minus B. Okay, students, I stop here today. In the next class, I shall give you examples of summation for trapezoidal fuzzy numbers. Since addition and subtraction are linear operations, it will be easy to compute the corresponding membership functions by establishing the linear equations. But if we go for multiplication and division, we shall see that the corresponding numbers are not going to be triangular fuzzy number at all, because we will get equations in quadratic equations in alpha. Therefore, we have to be more judicious in computing the multiplication and division for fuzzy numbers. We shall investigate that in our next class. Thank you.